Lunch.
Yeah, everybody that is anybody.
My intention was to see you at the treehouse.
Yeah,
And then when I couldn't
break from the treehouse a little earlier. Yeah, we're live. Acknowledged.
I was nominally here at 12:30.
4-minute warning.
So do I do my own slides, or
Either way.
It's push a button on that machine?
Yeah.
Which button?
You could either use this or push the arrow key.
Up and down. Ah, okay.
Up is the last page.
Down
Oh,
okay.
Is the next page.
The next page, yes. Okay, good. No, what I meant was this page. It would have been nice if it had said for what date it was. I know, but I was hoping it would say on the actual page. Too much to hope for.
Yeah, sorry about that. It's a web page. It's not designed. It's not laid out to be printed, really.
Aha.
Is that it would have like headers and footers, and the header would have meaning, the date.
Yeah. Okay.
I used to put the date up on the page header. But a couple of times I forgot to change it. So now instead of saying SVFIG October monthly meeting, it just says SVFIG monthly meeting.
Yeah, actually, I would like to be able to have a system that had 1,000.
So if you need to point at anything,
I don't think I do,
okay.
But
it's the green button here.
Ah, okay.
I'm a theoretician. My classmate is an observer. See, people think, oh, well, you're just being a theoretician just to make people think you're real smart. I said, no. It's not a sense of intelligence. It's a sense of economics. People who are observers have lots of money.
So what is your interest in?
Well, let me think. This is important. Because, even like a 30-inch, that's like $75,000.
Just the optics.
Yeah, just and your observatory and everything. Oh, it's a lot of money. And but theoreticians, you see, the observers, they're like Bill Gates and Elon Musk, these robber baron types.
Actually, I will have something to point to.
Okay,
all
good.
we need is just
The green button there.
Yeah. Okay. Good.
That's all we need. Yeah.
Use the data
Yeah. Oh yeah. Data mining, all that stuff. Yeah.
Well, I mean, use the Hubble on use all those space telescopes to get your raw data.
Yeah. You get. Yeah.
That's built your own.
Yeah. You can do data mining. There's many websites out there that have all this information.
You could tell a real astronomer in the older days because he had electrically heated long underwear.
Exactly.
And he knew how to stay up late nights and sleep during the day.
In fact, the guys who worked at Palomar, those guys had brass balls. Because that was one of the few telescopes. Not only was it cold, but it was a prime focus telescope. Which means there was an elevator that went up the sled, and then you had to step over into the prime focus, carry fly about this, huge. And you had to carry those things, and you had to load them one by one, do your exposure, and then after you get all that stuff, put it back in a package. And then this is like in the morning. Then you had to step out over into the elevator and then take it down. But let me tell you, that prime focus is way the hell up there.
They would strap James Bond up there and start slewing it towards the sun.
Oh, yeah.
Hey kids, what time is it?
But here's the thing.
1 o'clock.
Our friends at YouTube have told us that we're on the air. And it's exciting to hear that. If any of you are wondering why we start late, we start right on time. You're seeing the delayed broadcast. And without further ado, Jay McKnight, formerly of Ampex, now of MRL. What a guy.
Okay, thank you, Kevin. Yeah, as he says, I'm Jay McKnight. I took a degree in electrical engineering here at Stanford, graduated in '52, and then went to work for Ampex for 20 years in audio, research, instrumentation, a little of everywhere, professional products. And then was dumped out in one of their regular get rid of excess employees times in 1972. Went on to do Watergate tapes and found Magnetic Reference Labs. We make test tapes as a business. I was hoping we'd be out of business now and I wouldn't have to worry about it, but it turns out people are coming back to analog recording, so the customers are still there. In 1910, John Leslie and Ross Snyder, who had been employees at Ampex from near the beginning, wrote a history of the early days of Ampex Corp., which is the most accurate Ampex history, because it was written by people who were there at the time. Today I'll give excerpts from that paper. You can find the entire paper at the Audio Engineering Society's Historical Committee website, which is aes.org/ASHC. And at the top, if you search for Ampex, it will take...
We'll put a link in the notes and in the mailing list.
Okay, good, thank you. Anyway, search at the top for Ampex and it'll take you there. For background on magnetic recording, briefly, the relationship between electricity and magnetism, was discovered by Ørsted and Faraday around 1830. Magnetic recording was first published by the American inventor Oberlin Smith in 1878. The first magnetic recording had a wire medium, was invented by the Dane Valdemar Poulsen in 1898 and was called the telegraphone. And for the next 50 years, all the historical references that you'll find speak of wire recorders as telegraphones. Many wire recorders for voice recording were made in Europe, in the United States, from then until the introduction of coated magnetic tapes in the 1940s. But wire was really a non-starter. It's too heavy, too expensive, too hard to splice. Tape recorders and coated tapes were invented by the Austrian Fleumer in 1928 and developed by I.G. Farben. You probably know them as BASF, and AEG, which is the German General Electric, from that time on. The other thing necessary for low distortion and low noise recording is AC bias, and it was accidentally discovered, all 4 times accidentally, by Carlson and Carpenter, who were working for the U.S. Navy in 1920, but forgotten at the time and independently rediscovered by Wooldridge at Bell-Tel Labs in 1936, Nagai in Japan in 1938, Weber in Germany in 1940, in cameras in the United States in 1940. So now we have the pieces and we're ready to talk Ampex. The company was founded in 1944. They were making, they were a spin-off from Dalmo Victor, who was making radar, mostly I think aircraft radar, up in San Carlos, California. And one of their employees was Alex Poniatov, who was born in Russia in 1892. His father was well-to-do, and he sent Alex to Germany for education in engineering. Then he went back to Russia to escape to China, and ended up in the United States, where he worked for General Electric, Pacific Gas and Electric, and Dalmo Victor in San Carlos. Dalmo Victor needed small electric motors for their radar units, and they got Alex to found the company which they called Ampex, which people say is AMP for Alexander M. Poniatov and EX. I think that's a crock, actually, but that's what people say. The little company did quite well, but when the World War II came to an end, so did their market for small motors. They hired Myron Stolaroff, who was a Stanford graduate with a master's in electrical engineering in '42, to help them with the electric motor business. When the war ended, of course, the radar business ended, and it turned out there were lots of motor manufacturers that could make other motors, so their business sort of evaporated. When Alex was still with Litton, he had met Harold Lindsay, who was a mechanical engineer working there. He was interested in what we now call hi-fi, had systems with high quality sound with phonograph pickups, turntables, amplifiers, and loudspeakers. Early in '46, Alex and Myron thought Harold would be a good person to join them at their company. One of the things Harold did was sort of interesting. He set up his sound system at Tilden Park in Berkeley. He had big theater loudspeakers on a trailer, permanent trailer, and he would set this up at Tilden Park in Berkeley and play phonograph music for the visitors. Another person to know was Walter Selstead, who became active at Ampex. It turns out the whole original Ampex crew was UC Berkeley engineers.
You want to show us any of the pictures?
Yeah, he will.
Okay.
Hello. Yeah, Ampex. There's the famous Ampex sign. I don't know, it's still down, I guess.
It's going to be down. It's still down. It's not coming back ever. It's gone.
Well, there were people talking about its being a historical thing. Maybe they should revise it.
Right. They may have, but what you see there is no longer.
Yeah, oh yeah.
I think if anyone had half a brain, yeah, you would keep that.
Here's Harold Lindsay and Alexander Poniatov in their better days. Harold is on the left and Alex on the right. During the war, the German broadcasting system used the magnetophone tape recorders that had been developed there in Germany. And a number of Americans, I think almost all in the military, went over there and were interested in purloining the Germans' magnetic recording business. Amongst them was Jack Mullen, who had been at Palmer Films in San Francisco. On May 16th, 1946, Jack gave a meeting at the IRE, he gave a presentation at the IRE meeting in San Francisco of his German magnetophones. He had gotten permission to send a pair of them home, so he took them apart. He left the electronics there because he knew he could reconstruct them, but he brought the transports and heads and such, and showed them at this 1946 meeting in San Francisco of the IRE. At that meeting, the Ampex people, Harold Lindsay, Walter Selstead, Frank Leonard, and John Leslie were all in attendance and heard this new machine. As I had said, they were looking for a new product to market since the motor business had gone dead. And they saw this and thought that would be a good thing to do. And so Myron and Harold started working on their own tape recorder that they could make. The thing that they were most concerned with was whether they could figure out how to build the playback head. So they worked on that and did build a head that would interchange with the magnetophone machine, and tried it, and it turned out it did work very well. So they figured they were in business, and so they started. There were magnetic recorders in the United States starting in the middle of the 1940s that were wire recorders. And as I said, wire recorder is not a good thing. There were one or two tape recorders, and there was a manufacturer that was making a beginning version of magnetic tape. They were not very good machines. They were not professional grade machines at all. The story of sound recording and commercial use is kind of long and intricate. For instance, the phone company had developed a steel tape recorder, which they showed at the 1939 World's Fair. And it had AC bias, and it was a good sounding machine, but the phone company folks were dubious of this, because one reason people liked telephones was that there was no record of who said what to whom. And they thought, well, if there was a recorder available, it would discourage people from using telephone company equipment. So the telephone company had developed film recorders, optical recorders, and disc recorders, but they had worked on some tape recorders but never actually sold one. Harold and Myron worked 12 to 14 hours a day for about a year to make their machine. And by October 1947, they had a prototype that resembled what became the Ampex Model 200. And let's see. Here's the demonstration at the IRE. Let's see if we can point out. There is a tape recorder up here somewhere. It's there. That's the electronics that Jack had built, and underneath is the tape transport. But this is the excuse me, famous IRE meeting where this machine was shown and Ampex saw it. And that is Jack Mullen. No. Yeah, I think so. And I don't know who the other people are. They took their machine that Mullen built and set it up in Bing Crosby's studio in Los Angeles, in Hollywood. Bing Crosby was a big name in its day, and the studios wanted him to do the shows live, which meant doing the show twice for the time delay each week, and he really didn't like that. So when excuse me, when Mullen came with a tape recorder that sounded good, because Crosby had been doing the shows on disc recordings, and it is, believe it or not, possible to edit disc recordings. You have two turntables and two sets of discs, and you figure out where you're going, and you're playing one, and when it's time to crossfade to the other, you put the pickup down and crossfade to that. But the quality comes out pretty bad. One disc recording just makes it for quality, and two doesn't at all. It sounds terrible. It sounded so bad that the audiences complained that it sounded bad. So when Mullen came with his German tape recorders, everybody thought Crosby thought that was a great thing and wanted him to do it. So this encouraged Ampex to get going and have a recorder. It was called a Model 200A. They cost $4,000 each. And Crosby placed an order for 20 recorders. And he was, and Mullen was the distributor for these things. And hello.
You press the black screen button that turns the screen black.
Oh, sorry. There we go. So there is the 200A tape recorder in its day. This cabinet, which is, yay by yay high, I'm told was designed to be the same size and shape as the Scully disc recorders, which the studios had been using. And the electrical interface was similar, so they could truck out their old disc recorders and truck in their new Ampex recorder. And this slide, I am told, Ampex gathered every bit of test equipment that they owned and stacked it up there as background for this recording. Wave analyzers, oscillator, HP voltmeters, oscillator, a couple of scopes, a power supply, I guess. And that's Harold Lindsay working on one of the transports. That first machine used a literally open reel. It had a flange on the bottom, nothing on the top. It was oxide out. The electronics were down here in the bottom, were nice plug modules. It needed no controls because on the surface, because the disc recorder it replaced had no controls on the surface. So it was built that way. By the way, if there are any questions, interrupt. I'm interruptible. When they were building these machines, they subcontracted the electronics to a company run by Rudy Peterson over across the bay. And one of the employees there was John Leslie, who gave a talk somewhere here at Stanford, maybe 10 years ago, gave this talk at Stanford. And John, who was still in engineering school, worked for Peterson. They were working closely with 3M for tape. It turns out that people had been aware of the tape recording business before the end of the war or by the end of the war and asked 3M to help them with tape. They were used to making tape, making and slitting and coating and all that good stuff. So they were likely to people to get into it. And if anybody's interested, there is a nice detailed book on the history of 3M, of developing and making tape. Myron Stolaroff, who had been one of the two original employees, went on to go see his friends at let's get the right name, White Sands Proving Ground, because he knew they would be glad to have some kind of a recorder for instrumenting their vehicle tests out there.
Rocket launch.
Pardon?
Rocket launches. Telemetry.
Yeah, telemetry. What I heard about was mainly vehicle testing, a different kind of vehicle.
What year was it?
48, 49, 50, right in there.
Yeah, that's road vehicles.
Yeah.
Land vehicles.
Yeah. The first production 200 was April 1948, and it went to Jack Mullen, who used them to record the Crosby Show. As soon as they got it into production, they realized that they needed something less expensive and maybe less big than their $4,000 Model 200. So the next machine was the Model 300. Let's see. Oh, there's the 200. There's the 300. By now they've gone to a reel with a top and oxide in a smaller unit and one that you could get a control unit on top of. Pardon? Oh, yeah.
Did they get into that business as well?
Pardon?
Did they get into the washer dryer business?
No, I don't think so.
That was all tubes in those days, right?
Oh yes, all tubes. Down in the bottom, there's a.
You could eat your house with it.
That's right, you could. The original German machines and the 200 only ran at 30 inches per second, because that was as slow as you could go and get good quality with the tape that was available. About the time that the 200 came on the market, actually, 3M, well, they had been selling a tape that was called 112, that actually was a non-oriented tape. When you coat the tape, if you just leave it coated and dried, the coating process itself somewhat orients the particles. The tape is made with what they call fine particles, and the mechanical action of coating tends to orient the particles somewhat. But it works much better if you actually take a big magnet and orient the tape before it dries. Well, it's still wet and the particles can move around. And 3M came out with this model 111 right about the 1939 or 40. And that was the tape for 10 or 20 years. The 300, which we show here, runs both 7.5 and 15 inches per second. The better tape let them do that. The 300 had a different and better design of playback head and recording head, which Harold did. It turns out they made about 20,000 of these Model 300 transports. They were generally modified for instrumentation. If you ever saw instrumentation machines in the 50s, they would have been 300 based. When the 300 came out, when the 300 came out, of course, Ampex realized that they now had a machine that was smaller, cheaper, and much better than the 200. And they figured, customers are having sunk $4,000 into this machine. We're not too happy with the appearance of the 300s. So Frank Leonard, who's one of the engineers there, who I worked with when I first worked there, designed a new electronics for the 200 that made it work as well as the 300s. They sold these to, I guess, almost all of their customers for the 200s. And they sold them for about $1,000, and I'm told they lost another $1,000 on each one they sold. The instrumentation recorders, they made a Model 301 which was optimized for instrumentation recording. The equalization was changed. Speeds were accommodated. They devised FM electronics to be able to go down to DC, which you could not. Well, you can record down to DC, literally. It's no problem. The problem is playing back. The playback unit that is used is a Faraday's law thing and needs the flux to change back and forth to get any voltage out of it at all. So Myron, as I say, went down to New Mexico and drum up more sales for their machines. Yeah, for rocket launchers, you're right.
So
yeah.
these things had a much wider bandwidth when they're doing recordings.
Yeah. I mean, they were optimized for 20 kilohertz band for audio and ran speeds that were appropriate for audio. Some of the instrumentation recorders ran 60 and I think maybe even 120 inches per second to get a wide enough band. And like I say, by using FM, they could go keep the low end down, keep the low end working. And at this time, they made the first multi-track machines. They had a 7-track recording machine. Apparently that was, I think that was an instrumentation standard already for when they were using pen recorders. I think I mentioned Walter Selstead. He was another UC graduate, a friend of these guys, and he worked for Ampex. He did research department and ideas for other projects. One of the things they made in 1950 was called the Model 500. I don't have a picture of that, but it's an extremely low flutter machine where the tape wraps around the capstan and the heads are against the tape on the capstan, actually. And this was a fancy instrumentation machine that actually they never sold any of them. It was too expensive and too different from the other machines. So it's there, but not much use. Ampex soon after the 300, John Leslie and another Ampex engineer, Al Dinsmore, worked on making a tape of their own design, another tape recorder of their own design. And this is the models. Let's point at them. Okay, those are 300s. That one, I think, is a 200. Yeah, at Capitol Records, in a typical usage kind of situation, where they have a mixing console that feeds the tape recorders.
I got a quick question. Now, what I heard at Capitol Records in Hollywood, right?
Yeah.
That studio inside, that's on
a floating?
Isolated.
It could well be.
Yeah, because they were finding out that any vehicles driving by the building would modulate and would pick up into the recording.
Yeah, I believe.
Yeah, so I think this is the guys inside, they're looking in through that window. That's all, it's air isolated. They're on like bearings of some sort.
Put them on springs sometimes.
Or spring, yeah, something that
it's a floating unit.
Yeah, where it floats, because what happens, any vibrations that come through get dampened.
Yeah, it's a filter. It's a high pass filter.
So, question.
Yeah.
So, I mean, with all this, at this time, are they still have archives of this type of tape? Or generation, did they migrate like all the music to something new every single time? Because you're gonna like exponentially have to have more of each newer format.
Yeah,
right?
that's true.
Upping as
Yeah.
as the older
Since he doesn't have a microphone, just briefly repeat the question. Get the sense of it.
About archiving the tapes and when new versions came out and everything. Yeah. The old inventory of recordings is very valuable. They sell this stuff. Every now and then they rediscover some musician from the bygone days and re-release the discs.
you still, the thing is, let's say at this particular point in time, you have to have a 300 plus all the other stuff that it plugs into to be able to extract the sound, right?
Well, he asks, do you need other equipment to be able to play the tapes? I mean, the tape recorder is freestanding and it makes a signal from the tape, and you just connect that to another tape recorder and you can make a copy. And nowadays, I don't know how all it happens, frankly. But yeah, it is a problem. The tapes have a finite life. The magnetic pattern remains forever. It's not a problem. The thing that goes bad is the base materials of the tapes. They were originally cellulose acetate. Which does not last forever.
What we used to call gun cotton.
And later it was mylar, which lasts pretty well. But in the starting in the later 1960s, they had problems with the tape binder breaking down, and the tape will turn sticky, or the coating falls off, or what have you.
Yeah, actually, partly we're kind of in the tape restoration business. So the surface lamination that they put on there, not the actual ferrite, but that gumminess that you get.
Well, it's a binder, which is glue, and you mix the.
It actually gets onto the heads and stuff.
Yeah, it's a problem. It's a problem. It's a crazy thing. There are some tapes, even out of the same batch. Some tapes will be okay forever, and some tapes go bad. And they have worked at this. That there's a problem in that the manufacturing process is proprietary, so they don't want to share out with others, what materials they're using. They still struggle with the tape shed problem, yes, but you have to copy the tapes. The best practice is you keep the originals in case you need to copy it later, but you do need a copy that is not falling apart.
Well, yeah, a lot of it has to do with that, as you said, that coating that's over the ferrite, right? That it's streaming onto the head. That's what's gumming it up. It's not the actual material, the ferrite actually being shimmed off, right?
Yeah.
Because it's streaming, and we've found that emulsion is that's what's tacking up everything. So they came up with a way of testing the tape to see if it's how a single drop of water or some other solution sits on top of the tape to tell you if the surface is intact versus it being pitted. With this emulsion.
Yeah, the problem of testing for tape failure is very difficult. It's essentially impossible to accelerate a life test. I mean, there are ways of simulating acceleration, and it may or may not work.
Right. Yeah, I've ever seen this on TV. I think it was a Discovery Channel where abandoned salt mines are now used as archive places where movies and tapes are placed in because the atmosphere is so well controlled. But you still have to be able to go in periodically and make copies onto better media.
Yeah.
That's the whole idea, because like I said, this stuff is just way too valuable.
Yeah. Another place that recordings are kept, by the way, is Library of Congress. I forget its name. They have a branch that's 50 or 100 miles south of Washington, D.C. It's a bunker that was originally built to be atomic bomb proof. and whoever was, the agencies that was in there didn't need it anymore, and so they turned over to the Library of Congress, and they have storage facilities and transfer facilities and stuff like that.
Because I'm sure that the Library of Congress does that.
Yeah.
To periodically copy things onto more durable media.
Are there more durable media? You hope.
They're actually thinking of using glass as a recording medium.
I think we got off into the weeds.
Yes, we
Yeah,
did.
yeah,
Come
yeah.
on, Jay.
Sorry. Okay, so we got the instrumentation recorders. They sold a lot of instrumentation recorders. What else do we have? The four. And did we get to the, yeah. The next tape recorder Ampex built was the model 400. And they tried to save money on this by putting in mechanical system where you could use one motor and swing it back and forth between two pulleys under the reels. And this was supposed to be a big deal, but it was really pretty much a flop. The first one was fully mechanical. You had a lever you had to crank to start and stop the tape. This is the A model with push buttons and solenoids and stuff. It had what they call a pusher motor. It had the capstan over here instead of here. And I finally found out why. John Leslie says, oh, they were afraid of the field from the motor getting into the playback head and making hum. So they put the capstone over there. It turned out it was not a problem. But it's a great storyteller. Designed this new electronics for it. And this electronics became the basis of, this. This is the model, well, this is a 351, but this is the model 350 transport up here. And the next model, electronics. This model, interestingly enough, and people don't talk about this, but this goes back to the original magnetophone design. One design under each motor, a capstan motor, one motor under each reel, a capstan motor, and no mechanical frippery to change back and forth. It turns out it's the best way to do it. And it's been a very popular machine.
Was there anything more than a spring on that tension arm? Was there any control for the?
No.
It wasn't servo.
We did have a tension control in that position on a machine called the MR70 that I worked on in the mid-60s. But this one is just to take the jerk when you start the tape. It's not so elegant. I mean, you have this capstan running full speed and the rolls of tape standing still, and you push the button and the idler closes in the capstan and the tape is jerked up onto speed. The other problem in that respect when you have a machine like this is that it takes 3 or 4 seconds for the reel idler to get up to speed, and during the time it does, the tape is accelerating it, the tape tension is higher, so the apparent frequency drops. In '52, they introduced the first production run of inline head stereo recorders for both the 300 and the 400. It turns out the first stereo recorder actually was a magnetophone that had inline heads. The two gaps were right one above the other. In the United States, when people started doing stereo, there were various ways. One was when they were doing disc recordings, was just to record the two channels on two separate bands on the disc. On the tape recorders, the first stereo machines were done on magnecords. We didn't talk about it, but the magnecord was a unit that came in a 7-inch package for the transport and had plug-in heads, so you could unplug the other head and plug in two half-track heads and make a stereo recording. It was the first. It wasn't terribly convenient or satisfactory because of the spacing between the heads. Aha, there we go. Another machine they built was the Model 600. This was developed starting in about 1952. It's an all-mechanical transport, which has the usual problems. It was easy for that machine to develop a flutter problem, and it drove the manufacturer and the quality control and the customers and everybody else crazy. This was designed by a fellow named Jack Wernley, who, as a matter of fact, was a college roommate of mine. But it was considerably less expensive and considerably lighter, and the people for whom it worked loved it. The people for whom it didn't work didn't love it. Okay, now we get down to, we covered the 350. About 1953, several of the movie people became interested in widescreen multi-track sound systems. And one of them used 70 millimeter film. Ampex supplied some of those machines. I worked on some of the electronics. In '54, Ampex reorganized again, making different divisions. You don't much care about that, I hope. In '55, they did their first venture into out of professional products into consumer products, and they had a machine that sold fairly well. In '56, they introduced the first working video recorder. Everybody was working on a video recorder. The first ones John Mullen did using the original 200s that he had from Ampex, just running the tape fast and band splitting for the high frequencies. It never really came to anything. People worked on it, people announced it, people gave up on it. Ampex was working on a video machine starting in about 1952. They hired Charlie Ginsberg, who had been a TV engineer for one of the local networks. problem, how do you get the tape to head speed to be high enough to record the frequencies that you want to record at some reasonable wavelength? Walt Selstead is the one that came up with the idea of the rotary head. Let's see, do we have... This is the audience. They made a real production of the introduction of the video machine. They held it at a 1956 NAB convention.
Association of Broadcasters?
Yes. Everybody knows who NAB is. Not really. Not really.
Well, yeah, that too. We all got internet right here. We're asking, what's NAB again?
They haven't.
George has a background in radio. I have a background.
Yes, I'm twitting you. I don't have a picture of it, but this uses a 2-inch wide tape, and it was the first time there was anything like a 2-inch wide tape.
Is this the one you can visit at Stanford Library?
Yes, this machine is available to see in the library, Green Library. Also the Ampex Model 200 that I mentioned. There's one of those in a big plastic box. And you can see what the real thing looks like. Unfortunately, you can't touch it. Nor the video machine either, I guess.
I think the distinction is that the audio recorder actually works.
Oh, yeah. Yeah.
We have heard,
yes.
in this very room, we've actually heard audio from the audio recorder.
Yeah.
Play
Yeah.
back on an MP3 player.
Right. Yeah, Larry Miller did who was a FIG member, did the reconstruction of the 200 about 5 years ago, I think. It's been a long time ago. But the video machine, the NAB meeting, which is Chicago, I mean, that one was Chicago, and they trucked in the machine and set it up behind a curtain, and then brought in the audience under some other pretense, as I recall. And they opened the curtain, and they had been recording the earlier presentation on the video machine. So they opened the curtain, and there was this machine, and they rewound it and played it, and there was a glorious video picture off of tape. And they sold, I think they sold 45,000 machines at that convention at $45,000 per machine. One of the guys working on that machine, whose name you might know, is Ray Dolby. Ray had first worked for Ampex in 1948, making test tapes for the Model 200, which he apparently did just by doing a 1-to-1 copy, but that was better than nothing. Then he later worked on the the video machine and devised some of the circuitry that works. One project. One of the projects that John Leslie did in the 50s was looking at tape quality. They made tape recorders, and they made this good specification, and they realized that the ultimate limitation for the quality of the tape recorder was the quality of the tape. They'd set up the machine, it'd be flat out to 16 kilohertz, and then they'd put another roll of tape on it, and it wouldn't be flat out to 16 kilohertz. so he looked into the tape, and let's see. There you have that. Here are a couple more videotape things. I believe they've said that the machine was first used for a Douglas Edwards CBS News program, but their one is in use. There is the development group. If you want names, they are Charlie Anderson, who was alive until recently, Ray Dolby, who died a couple of years ago, Alex Maxey, Charlie Anderson, Fred Post. He's the machine. Yeah. Who was the machinist who made all this fantastic stuff. And there, of course, is their first prototype. It says here. Okay. I thought, gosh, he's smart. Ampex got a Grammy Award in 2008, would you believe? Which seems like yesterday. It was 10 years ago, down in Hollywood, and we went down to receive the award. They contacted me and said, "Hey, we're looking for some live person who can receive the award." This is the presenter at the show, and Gordon Strickland. Ampex, taking it down to the tail end, Ampex, 10 or 15 years ago, I guess, sold out the data, closed up everything else and sold off the data processing division to retained the Ampex name. And this is Gordon Strickland, who was the CEO of Ampex at the time in '58. There I am. There's Myron Stolaroff and John Leslie at the meeting.
Is that the rotating speaker, Leslie?
No.
Was that the adult video awards like John Leslie?
Indeed. No, John Leslie is. By the time John Leslie was born, I'm sure there had been Leslie Horns for a long time. It's an interesting coincidence of names, yeah. Back to audio, in 1957, they developed a consumer products machine. Yes, and I had mentioned tape, that John Leslie had done a project in the middle 50s about the quality of tape, and they evaluated samples from 3M and audio devices and Reeve Soundcraft and who else? Somebody else. To see who made the most consistent tape. And they decided that Or Radio, which made tape down in Opelika, was making the best tape at the time, and it was a company that they could afford to buy. So they bought that tape manufacturer, and it's a whole story unto itself about the tape manufacturer. they were in Opelika, Alabama, which is fairly deep south. And it's a completely different culture from anything you Californians know about, or at least it was in that day. They had problems such that John Leslie went down to Opelika to manage the tape plant when it was bought by Ampex. They had such interesting problems as the work was done by Negroes, of course, and their view of the world is that they should say whatever pleases the white managers. And so they would get crazy numbers on inventories. It had nothing to do with the inventory. They would tell them it was whatever the managers had thought it ought to be. So that was a problem John had to work on. They had another problem that the plant shut down every noon on Wednesday for a prayer session that lasted the whole afternoon. And this is bad news for a tape manufacturing plant, which is a continuous chemical process. They moved the prayer session, and it turned out when they moved it from being in the middle of the work week to being on their own time, that they were not so interested in prayers. I think actually that's much of the material. One of their they had financial problems every couple of years. They would lay off staff, and of course Ampex was pretty well known as the local training ground for electrical engineers. They would hire too many, then fire off some, and then hire again and fire off some. In 1961, somebody, I don't remember who it was, announced thermoplastic recording, and that made the Ampex stock drop way down because it was a competitor. And due to stock purchases, the majority ownership of Ampex by this time, 1961, was in the hands of large banks and financial institutions. And when the price went down, they dumped out the existing president and hired a new one. The directors brought in a fellow named Bill Roberts, who had been the manager of Bell and Howell in Chicago, who turned out to be, what shall we say, a real turkey that none of the engineering people could work with. And a lot of the original engineering people left the company at the time.
Roberts had, I think, his own line of tape recorders, or at least there was a tape recorder.
That's a different Roberts. Yes, there was, but it's not the Bill Roberts that ran Ampex.
One of the founding members of the National Association of Ozone.
So the company went on for another, 20 years or so, I guess. And as I say, they suffered mismanagement under Roberts. One of the things they did that was really terrible for the audio division is that one of these slick managers figured he could make a buck by setting up manufacturing in Colorado Springs, which they did, but they stopped making equipment in Redwood City a year before they got the new plant going. So for a year there, anybody who wanted a new professional tape recorder had to go to Scully or somebody like that. Yes, exactly. But they handed it to them, you know. And eventually they got back into manufacturing and were selling machines again. Yeah. I worked on a machine called the MR70, which was we hoped would be the ultimate audio machine in the mid-60s. But when it came out, they decided this new smart management figured they would set up manufacturing in Colorado Springs, where of course there wasn't anybody that ever seen this machine before that they were going to manufacture. And we had some troubles with that to get it going. And I think that's all I have scripted here. If you have questions, or I can go dig back more and read some of the other pieces if you're interested. Oh, okay. Thank you. No.
You had the picture showing there for a brief second. That's figure 12. Keep going. 13. One more. There.
Oh, okay.
These are the guys that wrote the article.
Yes.
Came from, and then
yeah.
Jay referred to make his
And I want to thank Kevin for transferring this from PDF to projectable slide.
Can we take 2 more minutes and talk about MRL briefly?
Whatever you'd like, sure.
I would be grateful if you would come back in December or early next year.
Uh-huh.
And maybe talk about your company and your methodology, Forth-based, I'll have you know, for recording test tapes.
Oh, okay.
Would that be a reasonable thing to ask?
You'll have to ask me in a year, but yes.
No, it won't be a year, it will be a month or 2.
Oh, a month or 2, I'm sorry. Okay, sure.
If you're really crazy
sure.
for it, and you can give, 20 minutes of this is the fourth that went into the... What do you mean recording test tape? That's what his company has been doing
since 1970.
There you go. He has, if somebody has a radio station or a recording facility, making records or whatever.
If you've got a tape recorder.
Their tape recorder. And let me tell you something, you really want to do that at least once a year. You want to align your tape recorder, you need a test tape. And as far as I know, when you wanted to buy a test tape at even the crappiest radio station, there was only one guy you'd go to, and it'd be Jay.
Well, in the 1950s to 70s, Ampex made these test tapes.
How much they know.
And one of the people at Ampex who worked in the tape lab was named Bob Morrison, and he split off with another company making test tapes, and then in the 70s we started also. So anyway, the fellow on the left is...
In the mid-70s, when I was in this business, nobody knew any of these guys' names. The only guy making test tapes, as far as anybody knew, was...
The guy on the left is Ross Snyder, who was the voice on the original Ampex test tape, and other things that Ampex needed a voice for. John Leslie, as I say, he was part of the UC crew, excuse me, that first worked at Ampex. He first worked at a company called Peterson Lab over in Hayward that built Ampex 200 electronics, and then he went on to be vice president of various divisions, including the tape division. And he wrote this paper, and like I say, the paper is on the AES website. Anybody who wants to read all the stuff that I didn't read.
Yeah, I wanted to say for the microphone that that'll be on the mailing list shortly. and in the meeting notes that Jay puts up on the website. But I wanted to ask you, would you rather do like 15 or 20 minutes on 4th day, or would you rather do a more extended talk maybe in December or January?
Well, if people are interested, I can talk more about it.
They don't get to decide. We'll email. We'll talk about it.
Okay. I mean, there's lots to talk about. If we want to get into the tech side, you know, even in this talk, this was intentionally a business-oriented talk rather than a technical talk. It turns out, interestingly, probably not surprisingly, almost all of tape development up for the first, I don't know, 10 or 15 years anyway, was purely, what do you say? I mean, it was not science-based. It was empirical. That was the word. It was a long time before there were really good theoretical explanations for how's the recording process work, how does bias work, why does it have the frequency response it has, and stuff like that.
Those days, they had a lot of FM, and that's what it stood for, ethic magic.
Yes, right. Okay, thank you.
Thank you so much, Jay.
And did I finally say thanks to Kevin for making the slides?
Yes.
Okay. And if you're interested, here are a couple of magnetic recording books. Here is the book by Joe Begun. This is 1949. This is, so far as I know, the first the first book that really explains tape recording and shows pictures of the existing systems and electronics and stuff like that. And this is Magnetic Recording, the First 100 Years by Eric Daniel, who's a British theoretician on tape recording, and Dennis Mee and Mark Clark. And it has a bunch of good histories in it for tape recorder. Again, it's not primarily technical. I have a shelf this long of tape recording books if anybody wants to read tape recording. And thank you.
And if you want to contact Jay, he reads the mailing list occasionally, and he may choose to respond. Yes. And if he doesn't respond, don't take it personally.
I probably will.
Well, thanks. Let's go to break.
So, Jay, one last question.
Let me unhook that for you.
Assuming that we, having
turn it off or leave it on?
For what?
this time.
You say when to start.
Stick it in your pocket. Now try not to touch it during your talk. Say when to start. Well, you got to say your name before you present.
Introduce yourself.
And then get on with it. Anytime you want. Google YouTube says get on with it.
Don Golding, I invented the Whiskers robot. This would have been 1991 time frame. And Whiskers is an artificial intelligence-based robot that is programmed in Forth. And he can do collision avoidance in real time. He just got pissed off right there, got mad. So Whiskers uses instincts, behaviors, and then the goal level, which is like the cerebral cortex. I sold a couple thousand of these, mostly into at the education market. I sold to Paxton Patterson and LabVolt, which is number 2 and 3 in the industry. And they went into high schools and a lot of junior high schools. I estimated over the period of time that Whiskers was teaching our kids that over 100,000 kids per year actually got their hands on this. So in 10 hours, just 10 hours time frame, a young person would learn the art of programming. He is a high level Forth. It was all Forth though. He learned about loops. They learned about variables, constants, and programming words, which of course in other languages we call functions. In Forth we call it words. The language was very English-like, so 10 feet forward stop is actual code. So it made it really easy for young people to pick it up and do programming. Now, if you gave Whiskers that command, 10 feet, forward 10 feet, stop, and he sees something at 3 feet, he automatically goes around it. He's an intelligent robot. So it's not like many robots like Legos, where you're just writing programs and they're running the program, and they don't have any intelligence to them. So, Dr. Ting and I were talking in the last meeting, gave a presentation, which I will continue after this announcement. And, it's been about 25 years since I've been in robotics, busy raising kids and everything else, engineering and all that. Time to get back into it. So I kind of look around. Most of the robots today are still being programmed. We want robots that at least have instinctual, behavioral type responses like Whiskers did. Whiskers used an 8 megahertz processor. I think it's 8. The max Forth, was that 4 or 8? Might have been 4 megahertz.
HC68, HC11.
That's it. Yeah, the HC11. And I used to pay $45 for that processor. And the new machine that we're going to design is going to be a 32-bit processor with Wi-Fi and Bluetooth. So what we're announcing is, and I'll talk about it more in Forth Day, it's going to be open hardware and open software. And I need our entire Silicon Valley Forth group to help out on this. So we'll get the hardware going over the next few months, but we have a lot of experts here. We need to build an intelligent machine. And we're going to build a very small, inexpensive robot, much like Whiskers, but much smaller. Will be more advanced than Whiskers and a lot less expensive. And we can get the maker community starting to be exposed to Forth. So what I'd like to propose, or let's say it's a goal. So let's say Forth Day a year from now, the day after, we actually have a robot event with these machines. And we invite the maker community, to participate, to see what it's like. we need to support C and Forth on this, right? Or Python or whatever. We want to get this out there. I guarantee you that a Forth-based machine is going to beat a C-based machine. Part of my background is I was technical vice president of the Robotics Society of Southern California from, we restarted it in 1989, and I was technical VP about 1990, and I don't even remember how many, it was a lot of years. I was technical VP. The president, whose name was Burton, and he was a C programmer, and he had a C business, and he and I were always sparring. It was really pretty funny, and so I gave lots of talks on robotics and Forth. I was developing sonar for robotics back then, which if any of you know Matrox, no, it's a Matrox. Bob. No. No. They make sonars. And Bob Gross, he was one of the members. He bought one of my Whiskers boards. He now has a 22,000 square foot facility just making sonars. And he got the idea of the sonars from the sonar work that I was doing and I was presenting about. And he's a good friend of mine. I'm glad to see he's successful. I was going after a much bigger area than sonars, and he was smarter and focused on one area, and he's doing really well. And we will have intelligent sonar on there as well, and I can talk to you about that a little bit later. So the thing that Forth has been lacking is a killer app. The thing that makes a language, take fire is a killer app. So when you teach a robot something, do you want to compile it? Do you want it to run slow? Our brains, we have an incremental compiler in our brains, right? We got the neurons that are learning things, and we learning things all the time. So we have an incremental compiler in our brains. That's what Forth is. Forth is an incremental compiler. It's also very stingy on resources. This new machine, based on Dr. Ting's recommendations, is going to be using what's the name of the chip? ESP32. ESP32, which has both Wi-Fi and Bluetooth. So we need somebody to write some of that code. So we need a phone app, right? So we can program this new robot just using the phone, but also a Wi-Fi app so people could use it in their homes. This machine will be as smart as a dog or a cat. It really has the potential, I'm not kidding. Whiskers, the entire language compiled down to 32K, did on a 32K PROM. It's an 8-bit machine running, I think it's 4 megahertz actually. It had 32K of battery backed up RAM, and obviously Forth extended into RAM. So you could actually develop very serious applications on Whiskers. Unfortunately for Whiskers Intelligence, I was more focused on building a robotics company than really pushing the technology that I designed. So initially in the 1990s, 1991-ish, I was developing Whiskers, and I had a background task that was doing the motor control. It was reading all the sensors, setting flag. I call them registers because they're 8-bit. They're shared variables basically between the background task and the foreground task. And in real time, all these registers are being updated. And if the left whisker is hit, there's a left whisker's flag register that gets set. If the right whisker gets hit sometime later, that register gets set. Now, the upper level software can actually read both, and they got a double whisker hit. Because in reality, these things don't always happen, you know, at the same time. So that's how I did it. And then you can clear the flag as well. So that's how you build intelligence into it. So then I had a goal level. So that's kind of like your main loop for the C programmers out there. Well, so it worked really well until, let's just say, you had this situation, right? So with the instinct level, you had a motor override, so whenever this one hit, it would pivot this way, and this one hit, it pivot this way. So it oscillated. It needed to make a decision. So I said, okay, we need a new level in the middle, which I called the task behavior level. So basically, I know you're all programmers, so I have this ISR that's running about 100 hertz, and at the end of the ISR, after all of the instinct level, all the sensors and stuff were updated, and ISR also generated the pulse width modulation. I did it in software. It would call the task behavior list word function. So what I had there was I had an array of CFAs that were being executed. So it's fetch, execute, fetch, execute. I had a word called priority. So you could say one priority, you know, double front whisker hit. You could say one priority side whisker hit. It would actually push it down. And I also have a delete task word where you could delete tasks. Now, the interesting thing about all this is when a behavior triggered, it can modify the task list. So it could change the behavior of the robot. For example, this robot here is collision avoidance mode, right? So you can see the wheels turning. Now notice it's singing at the same time. It's multitasking. When I touched that one, a behavior kicked in. It took processing away from the goal level, and then it returns back to the goal level where it left off. So it's a combination of preemptive multitasking and cooperative multitasking. So it's cooperative between behavior and goal level. It's preemptive, you know, instinct level on up. So there are 9 different motor commands, you know, from pivoting in place to the left motor forward, left motor reverse, pivot left, pivot right. Now, let's say a behavior triggers, and that behavior, like I showed you where it got mad, right? So I'm going to show it to you one more time. So it's called its frustration behavior. All right. Now I did that kind of as a lark. I want just kind of showing, you know, how you can create behaviors. But the interesting thing, it actually works pretty well when he gets stuck. And you know, I was just kind of playing around with it. And you notice I'm using because I'm delaying. I'm telling the wheels to go a certain way for a certain period of time, and I use a sound effect word as the delay. That's why you're hearing him sing at the same time or making some noise. I have laser, I got bird call, I got a bunch of different things. All right, so let's say after frustration, you want him to get mad and attack somebody. All the behavior has to do is set up all the instinct levels. So now when it sees something, instead of backing up, it lurches forward. Sees something on the side, it pivots around and lurches forward. Simple, trivial. So I did this 25 years ago. Our technology today is, you know, amazing. I mean, this is an 8-bit micro, and we're going to be using a 32-bit. So what's that?
And at a faster clock.
Oh, yeah, yeah. So we'll put a compass in it. We'll put electronic compass. I just wrote some good code on electronic compass in my last job. We'll use that. And may or may not put GPS on the first one. That's kind of an expensive chip. But we will have Wi-Fi, we will have Bluetooth, and I really need everybody to get involved with this project. It'll be good for fourth. You'll have a lot of fun. And I really want to make an intelligent, robot. So I took an AI course back in 1990, and I wrote a neural network in fourth. The instructor actually allowed me to do that, and I was talking about this a little bit at lunch. So because with fourth you can create compiler words, with create does, I use create does, and I created a node defining word where as parameters on the stack, you'd give it how many inputs it has, how many outputs. And then I had a word called link, which took the name of the nodes and the number, the input or output number, and it would connect those together. Now, what was kind of interesting about, and then also in that, the update procedure for each node is actually part of the structure that builds the node, and the CFA of the update word is called. So we could build asymmetrical neural networks. We could have a neural network with clusters of neurons to solve this problem, and a smaller cluster or a bigger one over here, and then connect them together. That's was my idea on playing around with that stuff. Or we could have, maybe the network is, maybe you want to, when the network is learning, maybe you want to kind of channel it and not let it go to certain extremes. Or maybe you want to play with genetic algorithms. Love your genetic stuff. Or fuzzy logic, or any other kind of AI kind of stuff. And very interested. We were going to have a Lisp guy who wrote Lisp in fourth. I'm very interested in that talk when it shows up. So basically, I put together this graphic. This morning I got a .com registered, and it's called theairprojects.com. AIR, AI robotics. So theairprojects.com, I reserved that this morning. So I want to get everybody involved in this. So it'll give us a great platform to show why fourth is so good at building intelligent machines. This is kind of what I'm going to be talking about on fourth day. Is there any questions or comments on that?
Well, as far as like GPS, I mean, I guess you could, Arduino has a lot of shields and stuff that one of them are GPS, which are actually quite inexpensive. So you could actually get, small Arduino with a, GPS shield and just wire it.
Well, that's
it. It wouldn't be on board, of course, but it would be like a kind of separate module.
Okay, that's a great idea. I'll tell you what. Let's put Arduino compatible connector pins on it. That way you can plug in all this great hardware, and that's a great idea. So we'll add that to the spec. Then you.
China for
Yeah, it's ridiculous. Yeah.
Especially in certain lots if you're, building them.
Yeah. So if it just plugs in there, and then you can start playing with the code, and you have all these boards that you can plug in. That's a fantastic idea. Yeah. How many AI guys are out there going to do some AI stuff? Come on.
I can help on logic. I haven't studied the programming side of that yet. It's pretty interesting.
All right. So last month I was going over the registers at the instinct level. I thought I would continue until my time is up. And then at the next meeting, I'll probably present to you a list of what I think the hardware should be. It's going to at least incorporate, Whisker's design is is pretty good about running around, and yeah. So I think it's something, much smaller. So maybe the whole processor board would be Arduino size, with a couple of small, inexpensive motors and wheels on it. Similar kind of design, and because it's Wi-Fi, one of the other things, I love solar, and I've started a solar company called Solar Power Corp. And so one of the things I want to do is put a solar cell on the top, and this little robot will get hungry, and I'll go look for light, window somewhere, and it'll take off, and it'll sit there for a couple hours, recharge, and it'll be kind of sad when it's going over there, make some sad sounds, and then it'll come back and be really happy and want to go find people. Do want to put a PIR sensor on it, so it can search for people. So this thing will be like a little virtual pet, a little robotic pet.
Now, is it going to integrate vision?
It's going to be a platform. Okay, so one of the things I did with this, were you here last month?
Yeah.
Oh, okay, so I showed you all my other robots.
Right.
Okay, so one of the things I did was, this board worked great, and I built some very large robots with this board. And I even have a network connector that I network the boards together. So this will be a similar sort of thing. You will be able to take the board out, and I will have a high power motor drive board that you can plug into it. I have some pins for that. So you could build any size robot. You could build a robot as big as a human. Distributed intelligence is really the way to go when you're building, a robot. Like if you're going to build a humanoid walker, you want to have, a dozen processors. Put processors around it, every joint, and network them together. That's really the smart way to do it, especially at $3-5 a processor now. It's ridiculous. So, yeah. But you kind of need to get started, learn the operating system and everything. I'm going to make the operating system I already designed. We'll work on porting it over, and we will make it open source. So you guys, if you want to start your own companies around this, go ahead. When I leave this planet, I'd like to see a bunch of fourth robots running around. So, need everybody to really jump in and participate on this. So,
one last thing about robots. I was since I'm scanning a lot of documents for the fourth project here that we're trying to do a fourth archiving project, I came across a 1980 article where in the back it presented one of those octangular robots of long ago, which look very similar to the robots today, which shows. The only thing that's changed is maybe that they've added different camera equipment and stuff like that, but it's relatively still the same. It hasn't really gone beyond what happened in the 80s.
I had a lot of grand ideas back then, and I am underwhelmed at the state of the art of today's robots. I mean, totally underwhelmed. After 25 frickin' years, this is what we got. The only one that really impresses me is Boston Robotics. Now that's fabulous.
They're the ones that did the four-legged robot.
Yeah, one and the panther-looking one.
Yeah, and also, the one where you.
Yeah, they have a vast selection of YouTube videos, some of which are kind of, how should we put this politely, a little scary.
Well, I thought they also had one where you could where a wounded soldier, could be transported.
Yeah, their robots are amazing, and it was a U.S. company, and it was sold. No, it's some French company or something. They're no longer a U.S. company. I mean, that was a real loss to me. Yeah, I think it was a European company bought them, but I'm not sure. But they're no longer a U.S. company. They were founded by MIT people in Boston. Really tremendous robotics.
Let me join you in the picture and talk to everybody on the net. Yeah.
Subsidiary of the conglomerate SoftBank Group.
There you go. Okay, Japanese bought them.
I think one has a lot of projects and projects have been initiated and have done quite a few things. But I think there's air for you guys on also, because Taiwan really has the advantage of making boards and making robots. And I think they have the added advantage that if they want to make things real cheap, they can go to China to reduce the cost. So I think if Don has the open hardware design, open software design, I think we can collaborate.
Exactly.
And get this done faster. Okay, I think it's not just limited to Taiwan. Anybody, England, German.
Absolutely.
Italy, anywhere. If you're interested, yeah, join us. And
I think once we get this thing operational, and we will write, a C version of it, because it really is not hard what I did. It was very much an aha moment, and I've used it ever since in embedded design. I kind of use this, I have an ISR in all my embedded designs, and I do this background. So I kind of have two levels always in every embedded design I ever do nowadays, from what I learned there. I never really had to have the task behavior middle level. It's great for robotics, but I really, in most embedded things like a solar controller, you don't need that. So I think this will really get forth involved in the maker market. So we give them the tools they're used to. We give them the C. We'll write the thing, because I'm a C programmer now. I've been doing that.
Okay, thank you.
Yeah.
Thank you, Don. Really appreciate and looking forward for your release of your open hardware.
Yes.
And then we can distribute it around and see what we can make out of it. Okay,
Yeah.
Thank you.
Probably have maybe the board designed by January timeframe. I've already been researching the sensors. Going over to China already, because their sensors are dirt cheap. So on our sensor over here is $10, and it's $1.50 there. So.
When the Chinese get regular customers, these sensors will start sensing you and talking to them.
The what?
Oh, when spyware or spy hardware gets small enough, you think you're buying a sensor, and you're buying someone else's sensor on you.
Oh yeah, I know. I read the article. Yeah, several articles on IoT and motherboards and everything else. But
you might also watch GF Robot.
I've heard of that one.
They have sensors in nice little boards and nice that you can throw anywhere. I've got a bunch of their sensors at work.
Mm-hmm.
So if you want to help contribute, how do we go about doing that? Do you have some kind of online chat or something? How do we get in contact about this?
Who would like to volunteer? I just registered the name, and I do have an account with GoDaddy. If someone wanted to work on the website and make a chat room and stuff, I can't do everything myself. That was one of the problems I had in the 90s. I was so busy trying to make a company, I really didn't have the time to spend on, because Whiskers, could be so much smarter than he is. And no one really I didn't have the time, and none of my users really, had the wherewithal. I was working with Dr. Ken Butterfield, if some of you remember him from Los Alamos Laboratory. He bought like my second Whiskers. He thought it was fantastic. And then I had written even the ISR in Forth, and it ran fine. But he goes, he's a master Forth programmer like you guys are. And he says, Don, I'd be willing to help you. Sure. Gave him all the source code. He rewrote all the low-level code in assembler. I didn't notice a difference, to tell you the truth, because a robot has to make decisions 100 times a second at the most. But anyway, he did all that, and we will, once we get some hardware. Actually, I could probably do it earlier. I could share the source code with you guys, maybe in December, something like that. And you can start perusing through it and see how I did things. But some of the stuff that Ken did, was an assembler, and we probably should rewrite it back to Forth because at today's processor speed, we ought to keep it in a high-level language, So that could either be the end of my talk, or we could dig deeper into the register stuff and in.
Well, I don't think we've concluded about the,
Okay, go ahead.
contributing thing.
Absolutely. You got more to say?
Website or, maybe having a forum or some way to.
There's a lot of online forums that we could, at least in the meantime, maybe just IRC or Reddit or I don't know how many. There's lots of places.
Would you like to volunteer and set something up?
I don't think it's that hard to set up. I guess it depends where you want to have the conversation.
I think that's the idea. Where's the conversation going to exist?
I don't really care as long as we have a medium. To me, that's a detail. I'm more big picture guy. So as long as someone wants to say, okay, I'm going to take care of this and I'll, manage the conversation, whatever you have to do, be the, what do they call it? Like you do. Yeah, kind of, manage the thing, make sure it's not. I'm on it.
Okay. And going forward, you can your own list on Zork, or just work with start using Zork or some other service for that purpose.
Around a long time. There's got to be a better way today with today's technology where, like if I want to upload schematics, it's kind of more of a web page kind of interface, but kind of database-ish or something, where, people maybe create a topic and then there's a thread and then.
Thinking this, if you want to pass the file around, you post it on G Drive. For a link and share it. And it doesn't have to be more complicated than that. If you really want to go crazy, the same place where we put our is actually
Microsoft Corporation
is actually a hub.
Great.
And there's actually a fourth hub where but it may be not necessary to get that complex. But there are lots of projects and projects out there that you can use, and a good part of it is free, especially if you're not going to be, making a big company out of it.
Keep in mind you want to. So, not.
Well, if there's someone that's not here that you want to talk to about that, Andreas knows all about the Hackaday stuff and so you might want to send him an email over the email list or send it to me, and I will forward it to him and give him your address and say, okay, Andreas, you know, you can either respond to this guy or tell him to bugger off passively by not responding. Andreas can sometimes not respond for protracted periods, but that's the way life is. But there's a lot, like you say, there's a lot of maker stuff going on out there, and they have their own places to hang out, like Hackaday. But you may want to look at this Fourth Hub stuff, and I'll post a link to the list. And see if that suits you as a place to keep your source files in your project. But GitHub is...
That's true. I have a GitHub account.
Something well, you know, that may be a place to put your project and your source code files and as a medium for the day-to-day communications that isn't, you know, sending the list out to everybody who's interested in this.
Yeah, we could do a GitHub for the source code. Make it public.
You know, other than George saying, you know, wholly owned subsidiary, they want to talk to like Sam Falbo or Brad Nelson, who both of whom are not here for whatever reason, about the details of that.
Yeah, Sam's
and
next month, I think we'll have a crowd.
But you know, even before then, you know, start posting to the list saying, here's the project, you know, who wants to talk to me about GitHub, or who wants to talk to me about email lists, or infrastructure that we could use to support this that we don't have to pay a lot for.
Yeah, it should. I mean, today's world, everything's free. You just got to watch ads, right?
But going into Fourth Day, it might be best to have a GitHub or a page on Fourth Hub or whatever.
Great idea.
You know, to have some infrastructure. But before you do that, you know, talk to Sam and Andres about the pitfalls and the methodologies that might best suit your goals. Free advice, worth what you paid for.
Yeah. Yeah. No, I like the idea. I'll release the source code before Fourth Day. I'll make that a priority. Probably, I think the first release anyway, put on GitHub and make it public, so you can like push people over there. You guys can start perusing through the source code and see how we did things for Whiskers. There's only some routines that are written in assembler that aren't Forth, and it was all new micros Forth, so which was, you know, standard Fig Forth. I think it was ANSI Forth. Anyway, it's standard. It's all standard Forth stuff. You didn't have any magic Forth words in there really. It's pretty basic Forth. And so that'll start us off, and then that you can get the Taiwan Fig group start looking at the source code, and if they want to build a competing board, go for it. It would be good to have a standard board. So
take a look and see if you can some way to make it.
Yeah, the funny thing about the LEDs, I spent a lot of time on collision avoidance sensors, trying all different things. I looked at reflectivity. You can actually use those, the photo Darlingtons I used for the receptors work great with IR. They go all the way up there. And so I did experiments. I put IR sensors on them, and I took a black piece of cloth, and I could see, and IR was like absorbed. But the visible light worked pretty damn well, even with a black, you know, non-reflective cloth. And plus, now you notice his lights are blinking. They don't have to blink, but it kind of looks cool. So I actually slowed it down, you know. I slowed it down enough to where you could see it blinking, but not affect its performance as far as the real-time performance of it seeing something. And that's also changeable in the fourth code. You can, just one variable determines that. So you can set it to where they're on all the time. They kind of look like lasers because they're being pulsed really fast. Because the way that the LEDs work is I turn the LED off, and then on a register, I sample the ambient light. I turn the LED on, I sample the reflected light, and then another register associated with each one of those is the trigger level. So that looks at, it's oh, that's right. There's another register called it's basically the reflected light register. I forget what I called it. Anyway, and then I had a fourth register called the trigger level. So the trigger level looked at the reflected light register, and if it's above a certain amount, so you have some hysteresis. So that's why you notice Whiskers, very smoothly. You can make Whiskers nervous by just squeezing down that trigger level to where it's starting to get a little jump, and now you got a nervous robot. So I mean, there's so much you could do with this architecture, and it's really simple. And with today's technology, it's going to be really inexpensive. And with a 32-bit processor, I mean, I can't even imagine, building code that would use it up, And then it will be networkable. So, if you want to put a Intel, i7 on there for doing some machine vision or something, you can network into it. So it will be expandable that way. But I'm very confident we can get like a $49 board, that we can sell, and I think the maker community would really, take notice, because if you look at all their videos, they're putting Legos together and they're writing software. We don't want the programmer to solve the problem. We want the robot to solve the problem. So the way the Triune OS works, it's like teaching a child. If you're in this situation, your sensor sees this combination of things, it triggers a behavior. So let your robot run loose and you see it get stuck, or get in a situation it doesn't know how to make a decision, you say, okay, what do the sensors look like? You're even reading the battery voltage, so and then you make a behavior for that, and then it's a priority list, right? So you stick it in the priority list where you think it makes the most sense, and when the robot gets in, you're teaching the robot. You're not programming the robot. We don't want to, solve all the problems. We want the robot to solve the problems.
So basically, it's building its own behavioral chart as it's doing itself, or its own kind of behavioral list of reactions, or
okay.
Are you mediating those particular events?
Okay, so yeah, when I wrote the network software, it compiled on Whiskers, but I never took it to the next level. So yes, we can create AI at the upper level that can
build its own word?
Yes, absolutely. You can't do that in C. You can't do that in any other language. Only Forth has, create does. C doesn't have that. I mean, they got structures and all this other BS. Yeah, but you can't extend the compiler. Only Forth does that. And then, so that's totally key to building an intelligent machine. You've got to be able to extend the compiler. You've got to have incremental compilation. These are things only Forth has. Robotics is the killer app for Forth. We just need to get it out there. And then, we get the maker community interested in this, and then Katie barred the door. They're going to be swamping our Forth groups. We'll be setting up groups all over the place. Now, when I release the, I think everybody's got the manual, right? I emailed it out.
It's on the website. Everything you sent me is on. Yes.
Okay, so everyone can get the curriculum and the manual, and I strongly recommend next week, you know, take a look at those things. Go through the curriculum first, because my goal for the Triune OS, for the language, was to have a human voice interface. So, for example, the registers are 8 bits. Obviously, variables are 16 bits. And then we have, you know, double variables. We want to get away from that stuff. Now, for Forth programmers, Forth is always there. You can do whatever the hell you want. For the trying to get the makers involved, you'll notice that I tried to create the words to kind of hide that. So I have a word called now in the language. When you define a register or a variable, it also defines the does. And then what now does is it goes and looks and sees, what do I need? Do I have to use fetch or cfetch? So we can build this more human-like language on top of Forth, because, you know, programmers, especially, we're going to get the entry-level programmers, you know. Do I use cfetch? Do I use fetch? You know, to fetch? You know, think in terms when you're writing code for the robot that it's a human, it's a voice interface. So try to not use Forthish, you know, low-level stuff. Try to make, you know, words and sentences that you can talk to the robot when you're coding. That's what I try. You'll see that that's what I attempted to do in it. 10 hours. Someone with zero experience in programming learned about constants, variables, loops, begin again, and also do loops. And they learned the basics of. So this, you know, not only are we, you know, getting Forth out there, but we very well could get back into the school market. You know, which would, I really enjoyed that, you know, being part of, you know, getting kids involved in programming.
Bertmine's kind of helping out in the technology in schools, and they have, you know, different robot project things that they buy. So this would be really fun if, you know, if it was small enough, or you could actually make it larger based on the motor controls and things you want it to do, right? The other thing is just, they mentioned, is Maker Fair is in May. So
we should have operational units by May for sure.
So even if we did like an introductory kind of, you know, potential, you know, what's coming maybe, and you know, have some kind of presentation that you know, we did with your ESP32 last a couple of years ago, where we are giving away ESP boards once they've worked on some Forth, which is done under MicroPython, right?
Yeah, we got the whole kinds of.
Yeah. So it was,
That's the one.
so we presented a lot of little projects at that time, which was really fun. All thanks to Ting.
That's the idea, this same sort of thing.
I think, I think that this group as a whole, especially myself, that we're mostly software thing. And I think we really lack the hardware experience to build robots. I would expect that you put your expertise on the hardware. You know, I think the battery, that's very critical. Battery and motor drives and sensors. And I think you put together a nice system, reliable and well functioning, you should be able to go out and people just have to solve it.
Yep, and I am totally committed to doing that.
Maker Fair, very receptive to this idea. I think we got two 10-feet booths because we plan we'll do tutorials here.
Mm-hmm.
And I think that if you say you want to do tutorial, you want to teach kids to do things, they'll teach you anything.
Yeah, they're big on education, and if you look at last year's and the year before, there's a lot of, of course, Legos is always there, right?
Yeah, they're the ones that bumped me out of the education market. So.
Right. But the thing is, there's a lot of other institutions that are out there that are helping trying to promote tech in different fields to different groups of people, different age groups and stuff like that. So. Not only is it good as a present, but we could invite these people to the booth at some point, and have a conversation too.
Right.
And that would, stir up interest in those different areas. At least a conversation. That's right.
Yeah. Well, when I was part of the Robotics Society, so we used to have a yearly fair, and we had one down at the Orange County Fairgrounds. And I had a booth, or we had a thing set up where I had a kind of a round circle, and I had whiskers running around in there. And 2-year-old kids would go in there and play with it, and they'd stand in front of it, and Whiskers would take off that way, and they'd run over here, and I say, look, beep, beep, beep. And he'd go, woo, woo, woo. The kids loved that. And then they just started making him mad all the time. But, yeah, it's a great interactive thing. So I would propose that a year from now, we have a second, right after 4th Day, we have maybe 4 hours of lecture on the robot, on what everybody's doing, and then the last 4 hours will be competitions. You guys can compete with each other. We used to have line following with this is so simple, it's not funny. You put 2 sensors down like this, and basically, remember I told you about the it's subtracting the light. So you cross couple that to the motor control, and now you have a line follower. No code, 0 code. Well, I made a line following robot for a museum in Georgia, and that's the one called Stockboy. If you looked at Angel's researches way back around 2003, 4, 5, you'll see the whole website. But it was about this big, and it had a conveyor on the top, and it had 2 LEDs, which were just 2 LED ports, and then it had 2 LED ports at the bottom, and I did have LEDs for collision avoidance. So you just drew a high contrast line, white line in the front or in the middle, a white line on each side, and it would servo pretty as you please. You can change it any way you wanted, and whatever the new course is, it would follow it. So it had this wide belt on the top, and it would come up, and then there would be a conveyor, and a box would come down. It would trip the LEDs, the belt would turn on, would pull the box on, and then it would go over to the end of the line, wherever it was, and it would dump the box off, and then it would come back and wait for the next box. And it used one of those controllers. So, once you have that controller as a basis, and like with this one, I created a high power board so you could have motors at 20, 30, 40 amps. I'm a motor control guy, so I designed a really great FET driver. I hate using N-channel FETs and that high side capacitance, boost circuit. Because I've seen a lot of blown FETs because it's a tuned circuit, and there could be situations where the FET doesn't turn on hard, and then it overheats the FET and it blows the FET. So I use P-channel FET. I use a H-bridge, but I drive the FET gate with, you guys remember PNP, NPN audio driver circuit, push-pull? So I drive the FET channel with that. I don't know if you know this, FETs have very high capacitance. The way that they get these things,
This is through the gate, right?
yeah, the gate has very high capacitance. I don't know if you know that. That's why some of these, these cap-based, things that are boost circuits that are trying to turn on the gate. There's a lot of capacitance in that gate. The way they get the RDS down, the resistance, is they have this big gate, and that drives the resistance down, which is what we want. We don't want the transistor to absorb any energy. The lower the resistance, the less it absorbs. Well, the downside is this high capacitance. So by using an audio push-pull circuit, it drives that capacitance sweet. I mean, because the collector goes all the way high or goes all the way low. There's no resistance. There's no RC time constant. I've never blown a FET ever. And I use that, and then I use because that circuit has to be the supply voltage of the motor, and if you want to use 24 volts or 12 volts, obviously that doesn't interface with the micro. So then I use a signal FET, that actually drives the push-pull transistor stage to do the level translation. That is a great power driver circuit, and it's totally reliable.
Okay, I talked to Don last week that we'll go to the Hong Kong restaurant for dinner. So any of you want to join us?
Fourth day?
No, today. Okay. Yeah. Whoever wants to join us, that welcome. I think we'll go there.
Sounds great. That was great food. Boy, that was something else.
More people, we can have more dishes.
Where is this? Where is it?
The Hong Kong restaurant. It's down on El Camino. Okay. If you go out onto El Camino, turn right, and looking for the Hong Kong restaurant on the left side out here. So it's I don't remember how many blocks. It's just
Okay.
You remember the name of the restaurant?
The Hong Kong restaurant.
It's called The Hong Kong.
My telephone will know where it is.
The 3691, 3691. How to know?
Oh, there you go. Yeah, that's Boston Dynamics.
Reindeer, huh? Yeah, that's
Robots.
scary.
Can you bring the one up where the one robot opens the door for the other robot? They're two yellow robots.
Yeah, one has a door opening.
Yeah, that's amazing. That truly is something else. Yeah, that's Boston Dynamics right there.
It was like the biggest problem with the Daleks is they couldn't go upstairs. I think these guys can go upstairs, but they can't open doors.
The new stuff.
The new one does.
Yeah, it can.
He's only on 2 feet now. They put it on 2 feet.
Yeah, it's amazing.
The video, the door opening video, the one robot, to the door and says, "Huh," and then I think it calls the door opening robot to come and open the door for it.
Yeah.
Well, this has to do with, both materials and mechanics, not just the software programming, just manufacturing and making.
See if you can find that one with the opening the door. It's fairly recent. It's called Boston Dynamics.
Should be easy. Is that a LiDAR on the top of his head?
Yes. Yeah.
They were bought by Google?
No, SoftBank.
Keep it over there.
Is he asleep? It's a conglomerate.
Yeah.
They bought up
Google bought them and then sold them to SoftBank. A Japanese, huge Japanese conglomerate.
Okay.
Google bought them first.
Sure.
They had another robot company and they sold them both at the same time to SoftBank.
Yeah, SoftBank is putting up a lot of money for things.
You guys remember Odetics back in the Odex one? I met Steve Bartholet. Yeah, the inventor.
I know what they're using it for.
And I believe that was fourth in there.
Really?
I think so.
Because I remember seeing, because I actually interviewed, that was like,
They're selling like
nineties.
hotcakes.
You know what happened?
They're going to use this type of.
They were right there at Disneyland.
As the control system.
And Disneyland started buying up all the
So
property.
it can be more.
But Odetics said no, until all of a
This
sudden
is
it
where
was just a little wordplay. And they're going, okay, we're ready to sell. Disney went, we don't care. Yeah, I've never seen Odette off of the corner.
Yeah.
You know.
It had a microprocessor. Yeah, there you go. That is such an amazing robot. It's eerie how lifelike it is.
Doorknob, hey? I know the doorknob guy. Hi, doorknob guy. Could you take care of this for me? Ooh, yes. Let me measure the doorknob. That's a number 3 doorknob. Eat it. I've got just the thing for the number 3 doorknob.
That's the one. I love this video.
Let's go.
Yeah.
Look at the smooth motion. Unbelievable.
Yep, it's terrifying. They say it reminds me of.
So
it reminds me of a few years back where they had this sniper. None of the SWAT guys wanted to breach, so they put an explosive on a bomb sniffing robot or remote control device, and sent the robot in to blow up the sniper. And a good time was had by all.
Well, that's a good background. You should let it run. So let's talk about this kind of robot in fourth. Okay. So when you make a robot like that, you're going to have multiple processors. You're going to network them together. Now, because you network fourth together, and we can download code into any robot on any processor on the network, and update the software, right? Can you do that in C? You got to replace the binary, right? Yeah, I know you can, but
while you're packing up and Dennis is moving up,
okay.
I'd like to point out that this is the Hong Kong restaurant. You get the 9-minute oil and bar. You get the Star One or Chevron, you go out and wait so far.
Is this the one going basically south on?
Yeah, south on the left-hand side.
As you go south, it's going to be on your left.
Okay.
Just before 9-minute oil and lube.
And what's happening there?
Ting and Don are going to have dinner.
Yeah, me and Don we're going to there for dinner. So anybody want to join us, welcome, because we can order more dishes.
Oh, so last.
We can order more dishes if more
dishes.
people are joining.
I like the food on the dishes rather than the dishes themselves.
Okay.
Okay. That's the only one I have.
We can rebuild him.
We have the
Which
technology.
pipe would you like? I will disconnect it this time. Show.
photos? What's up? It's not connected, I think.
Oh,
That's
was it
something.
there? It was just there. Of course.
And
Red October surprise.
doesn't work. Probably not, but we'll go the other way. Because we don't care. If it decides to come alive there, there we go. Let me make sure camera's doing something useful. Yeah, that's probably cool. Okay.
A lot of gold up there.
Not so much anymore, but it's still there. This was a Prince cruise up to Alaska from San Francisco. A lot of other pictures. This whole book, though, that I've got was made by Google. I just took the pictures. Google put the pictures together and added things like maps. And there's where we started into Alaska, Ketchikan. Went up to, I don't know where Petersboro Borough is, but yeah, probably. We ended up going from Ketchikan up to Juneau. And at Juneau was the Mendenhall Glacier Visitor Center. And then up to Skagway. And I'll go through the other pictures. From Skagway, we also went up to wherever this is, Haines. We effectively went up the fort. And, yep. Oh, I didn't want to do that. I want to go here. Slideshow. There we go. So now we just go through some pictures. Bunch of people all going along. That was the boat that it was on, the Grand Princess. Way too many people, obviously. My wife. And this is going out. A lot of fabulous scenery. And these are the few whales that we saw. Whale spout. That was probably more recognizable as a whale. That one I don't know where he was. That's a whale again. That's it for the whales. Now we saw, obviously, this is the middle of August. This is why I was not here in August, is I was doing this.
Beautiful up there.
Oh, it's beautiful. Great pictures. And Google did a good job of enhancing every one of these pictures. And
several ships in there.
Always. Way too many ships. Now this is the Mendenhall Glacier, which is only about 12 miles long anymore. This one's is going away very quickly. But you can at least get close to it and see the waterfall coming out of it. And you got as close as you're going to get to a glacier there.
That was the main reason we went on the trip. I've never seen a glacier. So it was cool. And icebergs along the way. That's still the Mendenhall Glacier. Then this is back, that was in Juneau. This may be actually Skagway at this point. Yeah, this is Skagway.
Snowblower.
Drill. Big drill. Yeah.
It looked like, well, boring.
And a museum. This train goes up further. All of this I did free, so didn't go on any of their excursions. The Mendenhall was one we went on. And then these were going up the fjord.
What's that?
Iceberg.
Oh.
Ice. And this is all the fjord that we're going up to actually see a glacier back up in there.
That cavern must be pretty darn deep.
Camera?
The cavern, whether it's...
Oh, it's a fairly big cavern to allow this big of a ship in it. Yeah.
How do you turn around?
I don't show that, but they did that up here, and that's how close we got to some of the icebergs.
Cruise ships have thrusters now.
Yes, they can just turn in space.
Yeah, they can go sideways.
And now we're getting to the big glacier that we saw. Here, another couple shots. There's the glacier.
They actually take the ship up there?
Yeah.
Wow.
We got that close to the glacier. And then turned around and came back. That's it, pretty much. But gorgeous country.
And you had daylight 24/7, right?
No, we did not. We did not. We're real far away from the Arctic Circle there. I'll show you again on the map. We're basically on the tip that goes down aside Canada.
How many hours of darkness did you have?
Normal.
Really?
Yeah.
6 to 8?
Yeah, it was. I didn't notice that it was really short. Because at that point in time, you have longer shadows. But otherwise, you don't really notice.
I bet you noticed how far up the North Star was.
I didn't go look.
Oh, you did?
No, I didn't really.
Not at night.
The problem is that anytime you're on the water, you have fog. It's the same here. Too much fog. And now we're getting back into population again. They're pretty small. They're pretty small, and it was interesting to now watch this new Titanic that they're launching pretty soon. That Oh, now we're repeating again. Where did I want to go?
I was reading about the new Titanic. It's supposed to be a really good replica of the original one.
Yes, and what I was going to mention is now they're welding. The problem with the Titanic was all just rivets. And the rivets separated. Now they weld.
Yes. Also the quality of the steel.
Yeah, the steel is much better.
Yeah, it had, chunks in it of carbon and voids and that.
Yeah, your is that it was even afloat. But that's it. That was quick.
There was a fire in the coal that softened some of the hull, and that may have contributed.
Okay, I see. Yeah. And actually, I can flip back to, seeing I still have some time here. There is differences between there's my picture, there's the Google picture.
Yeah, the purple mountain majesty.
Yeah, they added color. They added some focus.
Why?
Because it makes it look better. But I noticed them doing that. Yes, they aren't quite natural. They take away the fog.
I don't know. I've seen things that look like that. Unnatural just means you haven't had a lot of experience.
And you didn't put the right filter on. That's all they're doing is adding filters.
I think they are enhancing it so that
Yes, they are. Yeah,
the shading.
Yeah, you can see the pixelation, especially in the sky.
Yes, that's true. You can see the ridges.
But the water clarity as far as the ripples are enhanced, right?
I'm not sure it's actually, they can't add pixels.
No, but I mean, one to the other is definitely different.
Oh, they may be doing a smoothing algorithm on it. A sharpening algorithm, yes.
Definitely enhance contrast.
Yeah. But I saw that happening as I was doing it, and they said, "Do you like this one?" Sure, I like that. Okay.
You know what they could be doing is taking whatever is the closest, thing to the camera that it will sharpen up. Like if you look at the color green, right? It could be taking whatever's in the fold.
No, I can't look at the color green. Remember, I'm colorblind.
So anyways, in where you had this tip of the tree,
Yeah.
It's almost like they're taking whatever's in the foreground and enhancing it,
Yes.
color-wise.
It does look thicker.
I think it's the simplest that it's just increase the contrast.
Maybe.
Increase the contrast.
That's what I see too.
Yeah.
Probably to do a little bit of a level adjusting.
Yeah.
Bring up the brightness a little.
Yeah. And it was an interesting process to watch as it was happening here.
Are you sure that's not a snowblower?
Oh, is that what it is?
That's a snowblower.
That probably is a snowblower on front of a train, yes.
That is a railroad track snowblower.
Oh, okay.
Yeah, that would make sense.
It's the same type of mechanism that they use on boring.
Right, but with boring machines, they are cylindrical.
Yes, they don't have a scoop.
Yeah.
True, this is doing snowplow.
What camera did you use?
My phone, same camera. Well, actually, my phone broke in between last meeting and this meeting. This is a new phone, but it's the same model, only newer model.
So you had a broken phone issue last meeting, though.
Yes, but it wasn't irreparable. I dropped it again and lost the screen. And what they didn't include is the final stop of it was in Victoria. And Victoria was pretty. This is little tourist boats that they got going from place to place that were cool. Lobster tools. That was for the and the lobster meal on the boat was not near as good as the lobster meal that I brought back to the boat from shore. That was real good. But anyways, and that's Victoria.
Okay, now is that Canada? No.
This is Canada, yes.
Yeah, right.
Yes.
Well, you know what's weird? I was up there in like July. Yeah. And the thing is like the daylight when I was up there, I ended up always eating at a pub because by the time like 10 o'clock came along, the sun started going down.
Oh yeah.
And you're like, okay, now it's time to eat, right? The only place open are pubs.
Yes.
Hamburgers and fish and chips.
Well, yeah, I didn't really notice the time shifting that way, but it did. Going from here, it just seemed like a normal day. But anyways, that's it. Cool. Pictures. On this one, on this camera, and this was all taken with my old camera, and with that one had 2 SIM slots plus an SD card. So the amount of memory I had was how big an SD card I want. With this model, they took away, they shared a slot with the second SIM card or an SD card. So I can't have a lot of memory in this one. But still, haven't filled it up yet.
How big an SD card can it take?
If only a 128 easily. Anyways. Okay. Lights. Amateur pictures. Google enhanced.
I was curious when you said that, and now I sort of see what Google thinks is enhanced. They probably are actually enhanced, just flavored.
Flavored would be the better term. Is they're obviously not adding anything. They're just taking away and adding color. Okay. So we are done for the month. And we'll see you next month. Bye-bye.